Bismillahirrahmanirrahim. Hello dear students, I hope you are all doing well. I welcome you all to the class of O-level mathematics. Our discussion is continue on the linear inequalities in two variables, and in last lecture we discussed a problem that is related to uh, linear inequalities in two variable, and in that problem we discuss an example number 1, and this example is available in new Syllabus Mathematics series in this book written by Dr. Yeap Ban Har. In this example, our target is to find an unshaded region that actually represents the solution region of these given linear inequalities. In this book, in exercise 1A, these are some questions of basic level that are actually related to your example number 1. So in today's lecture, we will discuss some of the parts from question number 1. So let us start from question number 1. Question says, show unshaded the region satisfied by the following inequalities. The first pair of inequality is x greater than or equal to 0 and y greater than or equal to 2x. So first part is x greater than or equal to 0 and y greater than or equal to 2x. Right. So to draw or shade the given inequalities, in last lecture I discussed that when our target is to find an unshaded region, so in this case firstly we find the opposite inequalities to given inequality. So the opposite inequality is for x greater than or equal to 0 is x less than 0, and for this opposite inequality is y less than 2x. The second step is, now you find associated or boundary associated equation or also called boundary line. So next we find associated equation or boundary line of these two inequalities. So the boundary line or associated equation of this is just simply, this is an equation x is equal to 0, and for this y is equal to 2x. Now we draw the graph of these boundary line first, that are actually simple the straight lines. Remember, the graph of a linear equations is always a straight line. So firstly we draw the graph of these two boundary lines or associated equations, and then from those graph we will find the graph of these opposite inequalities. So x is equal to 0 is simply a y-axis. Remember, x is equal to 0 is simply a y-axis. So here we draw y-axis. Suppose this is our y-axis. This is y-axis. That represent x is equal to 0. This is a straight line, x is equal to 0 here. And suppose this is our x-axis. This is origin. This is x-axis. Next, uh, in opposite inequality, our sign is less than 0, x less than 0. X less than 0 mean we have to shade on the left side of x is equal to 0. When your sign is less than, it means you will shade to the left of x is equal to 0. So this can be represented as this area, that is actually your second and fourth quadrant. You know well, in your second and fourth quadrant, your x is always less than 0. So from this boundary line, we will shade to the left side, and this shaded region shows x less than 0 here. The area lies in second and fourth quadrant. Further, you can notice that because here in given inequality is equal sign available, so this line, that is x is equal to 0, is actually y-axis, will be a solid line. Suppose in our question, our given actual inequality is like this, x greater than 0. Then you draw y-axis as this, a dotted line. Your y-axis in that case will be a dotted line. Next we move to the second inequality. Second inequality is y greater than or equal to 2x, whose opposite inequality is y less than 2x, and the associated equation is y is equal to 2x. If you compare y is equal to 2x, this equation, with your standard form of a line equation, slope intercept form. This is the slope intercept form of line. This is the slope intercept form line. You know well, slope intercept form of line. In this equation, C represent y-intercept. Y-intercept mean a point where the line cuts y-axis. So here, this equation can be written as 2x plus 0. It means our y-intercept is C is equal to 0. Always remember, if a line or or a linear equation has a y-intercept equal to 0, then it always passes through origin. It means your line y is equal to 2x is passing through origin, something as, so we will draw a graph of y is equal to 2x. Y is equal to 2x. This is a straight line that passes through the origin and bisect first and third quadrant. So this is the graph of line y is equal to 2x. Next, because the opposite inequality has a less than sign, so we will shade when your sign is less than. Now as because in the first case our line was x is equal to 0, this line is only in one variable x. So in this case, x less than 0 mean left side. But when your inequality has two variable, then in this case less than sign represent below the line, below y is equal to 2x. It means we will shade below this line, So the area that represents y less than 2x is always below this line. So the shaded area, this shaded area is actually graph of the inequality y less than 2x, while this straight line just represent this graph of y is equal to 2x. So if you are unable to decide the direction of shaded region, I already discussed. You can use test point z, test point, but here test point will not work here because your x-intercept is, y-intercept is 0 here. So next we need to find an unshaded region, that is your required region. You can see here this yellow area shows the graph of x less than 0, and this area that consists on white as well as yellow lines, this is the common area. Now this particular area like as an open, this is a unbounded region. So this open area is a required region, unbounded region. This area is unbounded because you cannot bound this area with any closed figure. Mean to say, this is not in the form of any polygon like as triangle or a or quadrilateral, etc. So this is your required area that lies in first quadrant. This area shows the shaded shows the solution region of these two inequalities, that is unbounded. Next we move towards the next part. Suppose we solve now we solve B part. X greater than 2 and y greater than or equal to x plus 1. X greater than 2, y greater than or equal to x plus 1. X greater than 2 and y greater than x plus 1. So the first step is, what is its opposite inequality? The opposite inequality is x less than or equal to 2, because now at this time this inequality has no equal sign, so opposite inequality will contain x equal sign here. The opposite inequality of this inequality is y less than x plus 1. The associated equation to this inequality is simply your equation x is equal to 2, and associated equation to this inequality is simply y is equal to x plus 1. Now we draw the graph of these lines as x is equal to 2, where we can locate x is equal to 2. Suppose this is 0 origin, this is your x is equal to 1, this is your x is equal to 2, this is x is equal to 2. X is equal to 2, I already discussed that when x is equal to a means some real number, either negative or positive. Some real number, either negative or positive. Then this x is equal to a always represent a vertical line. So x is equal to 2 just shows a vertical line here. Vertical line. This is your graph of line x is equal to 2. This vertical line just represent x is equal to 2 here. No, but in our given inequality there is a greater than sign only, mean to say this inequality has no equal sign, so this vertical line should be dotted line, not a solid line here. It will be a dotted line. You have to see whether your given inequality contain equal or not equal sign. You will not see whether this inequality, that is the opposite inequality, have equal sign. You will see in your given inequality. As your given inequality has no equal sign, so the graph of this boundary line will be a dotted line. Now as the opposite inequality has a less than or equal sign, so graph will towards left or right. Yes, this will be left side, this will be on the left side. So this is the graph of this here. This region shows graph of the inequality. This shaded region represent the graph of x less than or equal to 2. This represent y-axis. This is your x-axis. Next, now we draw the graph of this line. As your line has now y-intercept, because it is completely in the form of y is equal to mx plus c. So when your line is always in this form, you can convert those line that line in to intercept form. So this line can be written as by shifting x on the left side, we have minus x plus y is equal to 1. This can be written as x over minus 1, y over 1 equal to 1. This is called two intercept form of line. This is called two intercept form. Two intercepts form of line. This two intercept form of line directly can tell us what is x and y intercept. So x intercept is the number in the denominator of x, that is minus 1. Similarly, the y-intercept here, the number in the denominator of y, that is 1. Now plot or locate this x and y-intercept on x-axis and y-axis. Where is x is equal to minus 1? Suppose here x is equal to minus 1 here. X is equal to minus 1, sorry. And where is your y-intercept? Y-intercept, y is equal to 1. Suppose this length, this point shows y is equal to 1. Now joining these two intercept and extended this line infinitely, this represent the graph of the line y is equal to x plus 1. But we have to shade the graph of this inequality, y less than x plus 1. Less than mean below the line. So below the line mean this area. This area will represent this blue area below this line, represent the graph of y less than x plus 1. Now at this time you can take test point 0, 0 to check the shaded region is away or towards the origin side. If you put y is equal to 0 here and x is equal to 0 here in this inequality, you will get 0 less than 1. Is this true or false? This is true. This shows that graph will be towards the origin. If it is true, then graph will be towards the origin, and if it is false, then graph will away from the origin, and in that case away from the origin mean graph will be above the origin. So simple trick is if your line has a less than sign, then graph will be shaded toward below the line. Now I just extend your vertical line. This was your first line, x is equal to 2. Now the common unshaded area between these two lines is this area. That is again an unbounded region. Suppose this is point A is a point of intersection, and this area is unshaded common area between two lines. That is actually the required solution region that will satisfy the given inequalities. Next we solve one question more. Suppose we solve a question in three variable that contain three inequalities. So let us discuss question number E part. Next we are discussing E part. Firstly, we find what is the opposite inequalities. The opposite inequality to inequality 1, x greater than 0, is x less than or equal to 0. Inequality opposite to this is 2x plus y greater than 10. And the last one, the inequality opposite to y greater than or equal to 1, this is 1, y less than 1. Next, what is the associated equation or boundary lines for each inequality? The associated equation or boundary line is just simply can be obtained by replacing these signs. Either your sign is less than, greater than, less than or equal, greater than or equal. For all these four signs, you just replace with equal sign. So the associated or boundary line of each given inequality is x equal to 0. The second one, 2x plus y equal to 10. And the last one has y equal to 1. Now you can see here the two boundary line are in one variable. This is also in one variable x, and this is also in one variable x. So x is equal to 0, this is a horizontal line, and y is equal to 1, this will be a vertical line. And as this equation has both variables x and y, so this is neither horizontal nor vertical, this will be an oblique line. X is equal to 0 is actually y-axis. This is your y-axis. So firstly we draw x-axis and y-axis here. So suppose this is your y-axis that represent equation x is equal to 0 here. Now what is the opposite inequality here? The opposite inequality is x less than or equal to 0. This shows that we will shade the region left to x is equal to 0 here. Left of x is equal to 0 mean to say this will be a second and fourth quadrant. This shows graph of this shaded region represents graph of x less than or equal to 0 here. Next one, because here in your original inequality there is no equal sign, so your y-axis will be a dotted line here, like this. This will be a dotted line. This will be a dotted line here. The next one is y is equal to 1. This is a vertical line. This is a sorry, I explained here wrong. X is equal to 0 is actually a vertical line. This is a vertical line, sorry, and y is equal to 1 is actually a horizontal line, sorry. This will be a horizontal line here. So y is equal to 1. Suppose this represent y is equal to 1. This height represent y is equal to 1. So y is equal to 1 is actually a horizontal line here. This is a this line, this horizontal line represent y is equal to 1 here. The next one, the opposite inequality for y is equal to 1 that we have made y less than 1. Y less than 1 mean we will shade the graph below the line. Less than sign represent below the line. Greater than sign represent above the line. So y less than 1 mean you will shade the graph below this line like this. So this shaded region by these red lines represent the graph of inequality y less than 1 here. This region is y less than 1 here. Last one. Your last inequality is in two variable. Further, you can notice that your given inequality has equal sign. So this line y is equal to 1 will be a solid line. This will be a solid line, not a dotted line. Your last inequality has a boundary line 2x plus y is equal to 10. As this line having both variables as x and y, so we convert this line in two intercept form by dividing on both sides by 10. We have 2x by 10 plus y by 10 is equal to 10 by 10. This will become x by 5, y by 10 is equal to 1. This shows that your x-intercept is 5. The number in the denominator of x is 5. This shows x-intercept is equal to 5. X-intercept is a point where the line cut x-axis. In the similar way, your y-intercept is here 10. So let us just extend this y-axis. Suppose this height represent y is equal to 10 here. This height represent y is equal to 10. Where is x is equal to 5? And this distance represent x is equal to 5. This represent x-intercept and this height represent y is equal to 10. Now we join these two intercepts. By joining these two intercepts, we have graph of the line. This green line represents the graph of the line 2x plus y is equal to 10. As the inequality opposite to this line is 2x plus y greater than 10, this is the opposite inequality. As the inequality has a greater sign, so we will shade above the line. Or in other words, in other way, you can take 0, 0 origin as a test point. That can help you to determine the direction of the graph. If you put x is equal to 0 and y is equal to 0 in the given inequality, you can see this will become 2 into 0 plus 0 greater than 10. The left side is 0, 0 greater than 10. This is false. This shows that graph is away from the origin. Mean to say your graph will be above the line. So your graph is above the line. This is your graph. This shaded area by the green lines represent graph of 2x plus y greater than 10 here. Lastly, the uncommon area that is actually here, all of these three lines. One is y-axis, your second line was y is equal to 1, and the third one was this green line. So the uncommon area or unshaded area is actually, this is a triangle. Suppose this point is A, this is not origin is here. This is A, this point is B, and this point is C here. So you can write it as unshaded solution region, unshaded solution region. is given by the triangle. This is your triangle ABC. This triangle ABC represents the unshaded solution region that satisfies given inequalities. So I hope you have a now clear understanding of your question number 1 of this book. In the next lecture, we will discuss first of all one of the important worked example number 2, and then later we will discuss a related question from your exercise. I hope today lecture was helpful for you. If you found my lecture helpful, kindly like, share. See you in the next lecture. Take care. Allah Hafiz.